Hi, and welcome to the Build Your Own Data Logger course, brought to you by FreakLabs and WILDLABS. I'm Jacinta from FreakLabs. This is Module 7, Testing and Piloting. So we've written our deployment code and assembled our device. Now let's test and pilot the complete system before we deploy it. There are many reasons a device can fail. It could be the hardware, the software, the mechanicals, or a combination of all. Because there's so many variables, some within our control, some not, our testing approach so far has been to build and test the individual building blocks of our system to give us confidence in the overall system. In Module 2, we did a sanity check on the hardware. We used the LED blink and Hello World sketches to check our Arduino IDE and board could communicate properly. This told us there was no bad components on the board itself. In Module 3, we wrote and tested the basic functionality separately before compiling it into the final application. By testing separately first, we were able to isolate any bugs to the specific components or peripherals, or our code. Now that we have a fully assembled device, we need to do some full system testing. Again, this gives us confidence in the device and also helps us troubleshoot better when we're in the field. The testing approach we take here at FreakLabs is to do accelerated testing of the complete device in 3 test environments. Accelerated testing means that we would, for example, take a sensor reading every 10 minutes instead of every hour, or we would set the threshold closer to the ambient temperature so we can take temperature readings more often. Basically, we want to hammer the system and see when it breaks. The 3 environments are the lab, the sandbox, and the pilot environment. In reality, there's often time constraints. However, we recommend don't skip the lab and the sandbox testing. Even 48 hours in each can give us confidence in the system. The lab is a controlled indoor environment with optimum conditions. This sounds fancier than it really is. The lab could simply be your lounge room, kitchen, or at a pinch, even a bedroom. But you want to make sure you have easy access to the device being tested. Optimum conditions means there's a consistent temperature and humidity, and we have access to power if we need it. For example, if we want to stress test the PIR motion sensor without worrying about draining the batteries, we can power the device using the mains. In the lab, we're getting a picture of the overall performance of the device. This is where we flush out the functional bugs, which could be software, usability, or hardware malfunctions. So we're looking at whether the sensors reliably trigger and log data, and we're waiting for any bugs that take some time to appear, such as memory leaks, stack overflows, or intermittent solder joints. In the lab, most failures occur within the first few hours, so a common practice is to run devices overnight in a burn-in test. We're also using the lab to start building a real-life battery profile that we can use as a basis for the field. Once we've tested in the lab, we take the device and put it outside in the sandbox. Then we run the same accelerated testing. The sandbox is an outdoor environment where we start to introduce environmental conditions in a controlled way. Again, it doesn't have to be fancy, your backyard or a park if you have access and permission. But you want it to be close by. If a device fails in the sandbox, you want to bring it back into the lab, so you don't want to be traveling too far between the two. Also, you'll want to easily update devices with the latest hot fix. A hot fix is a repair or upgrade of a working device. In the sandbox, we're basically exposing the devices to fluctuations in temperature and moisture. This exposes some uglier issues since humidity and temperature will change the shape of the circuit board and can cause intermittent failures due to bad solder joints. So basically, we're testing for reliability, sensor accuracy, and building a more realistic battery profile. Importantly, we're also testing how robust our enclosures are. We're checking if water gets inside the enclosure, condensation builds up, the system gets too hot, etc. In the sandbox, we're also able to test particular environmental conditions that will be in our deployment environment. For example, if we're deploying in a cold environment, we can put the device in the refrigerator. Although not technically outside, we'd still consider this a sandbox environment because we're testing an environmental condition versus basic reliability. The sandbox is also useful to get a sense of how easy an installation is and how accessible our device is once it's outside. The pilot site is as close to the deployment conditions as we can get and gives us the best indication of how our devices will perform in the field. It should be in a fairly wild environment and also painful enough to get to that if a failure occurs, it's a hassle. Piloting takes more time and resources, and so by this stage we should be confident in the system, otherwise it can become a waste of time. At the pilot site, the environmental conditions are completely uncontrolled, but we're expecting the devices to be functioning more or less autonomously, again typically with accelerated testing. We're monitoring all the same parameters as the lab and sandbox and hoping to catch stranger fails that we couldn't easily create ourselves. For example, insects and animals claiming a home, or high winds blowing our mounting down. Once the piloting's been done, then we move into deployment. Here's a quick graph of the lab, sandbox and pilot environments and how they lead up to a deployment. Before we move on to some basic troubleshooting, here's a few quick tips. Always do lab testing and some kind of sandbox testing. It's so important. Often there's time constraints and testing gets cut short, but even 48 hours of testing in the lab and sandbox is valuable. And if you're thinking of creating your own sandbox experiments for water, cold, heat and motion sensing, you can check how waterproof the enclosures are by submerging them in a bucket. Put devices in the fridge to test extreme cold, or put them in a transparent container in the sun to test heat. If you want to test motion, put the PIR motion sensor in a box, wave your hand in front of it, and check the logs to make sure it matches when you triggered it. So now let's go through some common issues on the WildLogger that might come out of our lab, sandbox and piloting. If you're getting a shorter battery life than expected, check the LEDs are off, the batteries are full, and the code you're using has power management. If you're getting inaccurate temperature readings or sensor readings, check the sensor is in the correct connector and the cable wires are in the correct order, especially if you've disassembled the cable gland and harness. Also check the batteries are full. Sometimes a low battery means the sensor doesn't have enough power to take a proper reading. And again, check your software is correct. If all that is looking good, try swapping out the sensor. If you're getting missed readings or missed motion triggers, again, check your cable wire order and the connector socket is correct. Check the sensitivity and duration dials on the PIR motion sensor, and also check the real-time clock is updating every minute and the coin cell battery is in securely. Also try paring down the code so it's just the basic functionality and testing, and check the PIR and temperature sensors are working independently. If all is looking good, again, swap out the sensors. So that wraps up Module 7, Piloting and Testing. In the next and final module of the course, we're taking it into the field. We'll be looking at field kits and troubleshooting.
It's the